Hey guys, welcome to the start of a new topic. We covered this previously in the Year 8 content, but we talked a lot about congruence and in particular congruent triangles in our Year 8 geometry topic. Now I'm just going to jump straight into using congruence in proofs. So this idea of proof writing and justifying why two triangles are congruent and what makes them congruent. So let's go straight in here. I'm assuming that if you're watching this now, you have at least come across the types of congruence proofs, how we can say that two triangles are congruent, and you know some of the basics of geometry. So if that's not you, please go back and either review some of my previous videos or look at your own personal material and in your textbooks or whatever, and come back to this video because we're going to be working a little bit quicker because I've already touched this in previous videos. This is just introducing the new topic. Now, I want to prove here that these two triangles are congruent. So in other words, that this triangle is identical in every way to this triangle. How do we want to do that? Well, we want to pick up on any things that are given to us in the diagram and any things we notice, and we want to come up with 3 reasons why these are identical, why these are the same or congruent. Now, if you remember the previous video where I started introducing you guys to these congruence proofs, this is kind of structured like an English essay, right? We need an introduction, a body, and a concluding statement. So we want to first introduce the two triangles. So we're going to say in triangle ABC and our other triangle, we want to write it in the same order, right? With the corresponding points as well. So I have A and C the same, and I'm going to put my D in the middle because this point on my second triangle corresponds to this point on my one up here. So we want to, anytime we talk about sides or angles or even stating our two triangles, we want to follow the same order. So have the corresponding sides matching here. So A matches with A, B matches with D, C matches with C. Okay, now that we've gotten that out of the way, let's actually look at what the diagram is telling us. Well, one thing is that we're given by these little lines here, that in geometry tells us that this is equal to this. So I can write in these two triangles, AB is equal to side AD. And this is given, we are given the equal sides in the diagram. So we can write given equal sides. Now, are we given anything else? Well, we can see these two angles are both 90 degrees. So they are the same. They are equal. So I can say angle ABC. So remember, I can list angles as just the two sides where the arms are of my angle, and with the vertex, the middle point of my angle, this B here, being written in the middle of my angle notation. So angle ABC equals angle ADC, and this is given equal angles. So given equal angles. And do we notice anything else here? Well, I don't know about you guys, but I can see that this side AC belongs to both my triangle ABC and ADC. And it is the same length for both because it is a common side. So we can say that here AC is common to both triangles. Now, we want to write a concluding statement about congruence. And to do so, we want to choose one of the 4 ways that 2 triangles can be congruent. Now, if we remember from last year's content, this can be 3 sides all equal, 2 sides at an angle. Now the angle being the included angle, the one in between the 2 sides being equal. We have angle, angle, side, and we have a right angle, hypotenuse side here. So we want to list the types of things we notice. So AB equals AD, that is equal sides. So we have a side here. Now, the angles being equal, that could be angle, but it's a special type of angle. These 2 angles are right angles. So that already kind of gives away which of these proofs we're using, but let me write that here. This is a right angle, and both of these triangles are right angle triangles. So there's a specific congruence proof we always use for these. So we have a right angle, we have a side, and the final side AC we found that is common. This is, in these 2 right angles, the hypotenuse of both ABC and ADC. So this common side is the hypotenuse. So we have RHS. So the 3 key bits of information point to the proof being RHS. And we use these 3 points to make our concluding statement. So we're going to say, therefore, do these 3 dots to say, therefore, the triangle ABC is congruent. Remember these 3 horizontal lines? These mean congruent. So it is congruent to or identical to. We have ADC. So this thing here means congruent to. And in saying that it's congruent, we just want to write which of the congruence proofs we use. So this is RHS. This is an exercise in how we can spot different things in our diagrams. Some of them will be given to us. So you can see these lines, these equal lines were given, and these equal angles were given. We can spot anything that we see, but we can also we may have to think a little harder and go, all right, well, I can see a shared side as well. Because in order to say 2 triangles are exactly the same, we need 3 bits of information. We summarized this idea when we first talked about congruent in the year 8 content. So please revisit that if you're still a little shaky with this topic, at least the context of this topic, because I gave a pretty thorough thing there that you can look at and see for yourselves. Okay, now we're going to do another example here, and we are not so much proving congruence here. We are proving congruence, but we are using this to prove some other geometrical results using congruence. That will all become clear pretty soon. Let me just write this out and label everything, and then we are going to try this question. Okay, so I want to first prove that the triangle ABC is congruent to the triangle EDC here. So I'm going to first introduce my kind of key players, my two triangles here. So I'm going to say in triangle ABC and triangle, jokes, let's do that up here. And remember, I want the kind of corresponding sides here. So I can see C is my shared point for both of these, but I can see E is the point that's as far away from C as A. So these two are corresponding points here. So instead of A, I'm going to write E because I'm talking about my second triangle. And my side corresponding to B is going to be my side D. And C is the same. So I'm going to write that here. And I want to now list all the things I can see. Well, two things here are given to me. And that is that AC is equal to EC. Because these lines tell us that in geometry. So I'm going to say that AC is equal to EC, and this is given equal sides. That is told to us in the diagram already. Now also, side BC and DC are also equal. They're given to us by these line markings. So BC equals DC. And that is also given equal sides. Now I'm just going to put these quotation marks for the purpose of efficiency, because I've said it already before. So I'm going to use the same reason, because I've been given another two sets of equal sides, which are given to me. And now I'm left with figuring out one more thing that makes these the same. Now let's consider, feel free to pause the video and try this on your own. I would encourage you to do that, because obviously me or any other of these video tutorial creators aren't going to be in your exam with you or doing the homework with you. So please feel free to pause the video and try to spot any third commonality between these two triangles, because you're going to be having to do this anyway. Now I can see that something about this angle at C and this one here, just by looking, they look kind of the same. But I also know from what I did in geometry previously, when I talked about angles all those videos ago in the year 7 and year 8, is that vertically opposite angles, so angles that are opposite each other, are always equal. So I can state that my angle, I'm going to call this ACB, because remember, my pointy bit where the angle is, that letter always goes in the middle. Now that is equal to picking the corresponding point to A, which is E. I'm going to say this is equal to ECD. And my reason is these are vertically, so I can say vertically opposite angles are equal. That's my reasoning here. So now I have 3 points that I have stated. So I want to see what aspects of triangles have all these proofs had to do with. So this first one had to do with sides. This second one had to do with sides. And this last one had to do with an angle. And the angle was the one in between my two equal sides. So this is the included angle. We talked about this in the year 8 content. So I'm dealing with side, angle, side. That is the proof I'm going to use. And that angle has to be the included angle, the one in between the two equal sides here. So I'm going to make my concluding statement now. I have my intro, I have my body. Now I just want to write my conclusion. So I want to say, therefore, triangle ABC is congruent to triangle EDC. Is that the same way I wrote it up here? Yep. And I want to give my reason. This is by side, angle, side. Okay. What we're going to do now, because this was part A of my question, I want to look at part B of my question here, which is I want to hence prove that AB is parallel to DE. That's what this symbol means here. This means parallel. We've talked about this before. Now, I want to prove that this is parallel to this. Now, how do I even know that? What's something we remember that tells us that two lines are parallel? Well, remember when we had two parallel lines and they got cut through by some transversal, some line that goes through both, some angle relationships came about. We had, remember, these ideas of alternate angles. So the angles inside this Z were equal. So if these two lines were in fact parallel, these two angles should be equal and these two should be equal. But we've already proved, guys, that these two triangles are congruent. They're exactly the same. So they're corresponding, the angles that we have in those are going to be equal as well. Because I have that this side is equal to this side. Therefore, this angle is going to be equal to this angle. These are when we talked about in previous videos, we talked about the angles of equal sides being equal, right? If a side, say AC, is a certain length and EC is that exact same length, this and this must be equal to. In the same way, the sides BC and DC are equal, so angle E and angle A must also be equal. And also, if we change the orientation of these triangles, we would see, well, we've already proved they're congruent, so they're identical. And then we would also just match up, okay, well, B is the corresponding point to D, so this angle and this angle are the same because they are the angles at those points of congruent triangles. So we can say they are equal. So we can say from what we learned, since ABC is congruent to EDC, since these are congruent, then angle BAC, so for example this angle here, BAC, is equal to DEC. BAC is equal to DEC. And we can write these are matching angles in congruent triangles. And we can say the same about angle ABC and angle EDC. But we only need one pair of matching things to say that, well, because these are equal, Therefore, AB is parallel to DE. Why is this? Because it has alternate angles that are equal. So in other words, because this angle is equal to this one, inside my little Z here, these are an example of alternate angles, and alternate angles only occur when AB is parallel to ED. Oh, sorry, AB is parallel to DE. So, using what we knew about congruence, we just picked off, okay, well, I can see there are equal angles, and because there are equal angles, they are special types of equal angles. They are alternate angles because they make this Z shape, and alternate angles imply parallel lines. You cannot have parallel lines you cannot have alternate angles without parallel lines. So that is sufficient proof to say that the line AB is parallel to the line DE. But this is how we can use not only congruence in proof, but to uncover further geometrical results, like we did in this part B, by using congruence. But thank you so much for watching this video, guys, and I will see you in the next one.